Welcome to your Unit 3, Lesson 6, Part B notes. We're going to continue working through our sinusoidal function transformations. So consider how you evenly space the 5 key points. It is possible to summarize this procedure using 2 different methods. So we can find the endpoints for the first cycle of trigonometric functions in 2 ways. Let's explore. So method 1 is where you take your C over B, which is what we've been doing, to find that phase shift. And then that's where we do our starting point. And then we add to it a full period. And then that would get us to our ending point. Oops, sorry, I was supposed to write that down below. So C over B plus 2 pi over B. So then method 2, if we don't factor out, so if we just leave it as bx minus c, we're going to start at c for our beginning, and then our end is just going to be a full period. So let's see what this looks like. So use first and last points of one cycle to divide the interval into 4 equal segments, kind of like we've been doing already. Me personally, I use method 1. If you want to use method 2, you can use method 2 also. So if we needed to find the amplitude, period, and phase shift for y equals 2 cosine of 2x plus 3 pi, and then we want to graph it. So our amplitude is 2. Our period is, so my b is 2. So my period is 2 pi divided by 2, so pi. And then we need to figure out what our phase shift is, right? So my C in this case is 3 pi. So my phase shift is going to be 3/2 of a pi. C divided by B. And we're moving to the left because of the plus sign. So again, if we think about our cosine function, starts at a max, goes to an intercept, goes to a minimum, goes to an intercept, then back up to a max. Moving to the left, so negative 3/2 a pi. We're going to end at a max, so negative 3/2 of a pi plus a full period of pi, so it's 2 over 2. So we're going to be at negative 1/2 a pi. And then we quarter our period. So quartering pi is 1/4 of a pi. So negative 3/2 plus a quarter. So I'm going to convert 3/2 to have a denominator of 4. So that beats negative 6 over 4 plus a quarter would put me at negative 5 over 4. Plus another quarter would put me at negative 4 over 4, which is negative pi. So negative 4 over 4 plus a quarter would be negative 3/4, plus another quarter would put us at negative 2/4, which is negative 1/2. So let's go ahead and plot those. So negative 3/2. We said we had a maximum amplitude of 2 at negative 1/2 a pi, amplitude of 2. Halfway down, we're going to have a amplitude of 2. Threw me off. There we go, amplitude of 2. Negative pi, amplitude of negative 2. And then we have our intercepts happening at those quarter marks. And then we can just kind of fill in the rest to keep the pattern going. Dot, 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 to make as many dots as we want. And there would be our curve. Okay, when you have your assessment, make sure that you either have these shown. If you don't show it here, then make sure you label at least one of your max values. So negative 3/2 pi 2, one of your min values, negative pi, negative 2, and your intercepts. So negative, what was this at? 5/4, comma 0. That's really bad. Maybe this was a little bit easier to label. Okay, Example 8. Given the equation y equals -2 sines, now we're reflecting it, 3x minus 6y, describe the transformations that occur from the parent graph. Then sketch it. So we definitely have a reflection over the x-axis. We have a vertical stretch by 2. My period is changed. My period is going to 2 pi over b, which is 3, so 2/3 of a pi. And then we have a phase shift to the right because of that minus. And then my c is 6 pi divided by 3, so 2 pi. Okay, so now let's figure out where we're going. So my c over b is 2 pi. So sine function starts at an intercept. We're going to go down to a minimum, back up to an intercept, up to a max, back to an intercept. We're starting right 2 pi, so at 2 pi. 2 pi plus a full period, so 2 plus 2/3 is what, 4/3 of a pi? 2 2/3. Yeah. No. I can only do math. It's Monday morning, guys. 8/3 of a pi. Okay. Halfway, so 2/3 of a pi quartered is 2/12 of a pi, which is a 6 of a pi. So every 6 we have something happening. So 2 plus a 6 is 13/6. Plus another 6 would be 14/6, which reduces to 7/3. 14/6 plus another 6 would be 15/6 of a pi. And 16/6 of a pi is 8/3. Okay, so let's see what this looks like on our graph. So starting at 2 pi, we said we have an intercept. Whoops, I'm already running out of room, so that means we're going to have to go backwards. So I originally would be going down, but now we're going to go backwards. So 2 minus a 6 is 11/6. So at 11/6, we're going to be hitting a maximum of amplitude of 2. And then minus another 6 is 5/3, so intercept. And then minus another 6 is 3/2. So that's going to get me down at -2. Minus another 6, it should just be every unit there is 4/3, intercept. So we can kind of see the pattern happening and keep on going for as many dots as I want. There we go. I'll make a nice smooth curve. All right, there it be. Okay, let's just keep on graphing. Example 9, determine the amplitude period midline of our graph. Amplitude we know is 2. My midline is going to be y equals 3. My period is going to be 2 pi divided by 1/3 of a pi, which is just going to be 6. All right, so that means, and we have no phase shift, right? So that cosine starts at a max, but we're reflecting, so min, intercept, max, intercept, min. We're starting at 0, ending at 6. In between would be 3, 3/2, and then halfway between 3 and 6 would be 9/2. So at 0, we're going to have a minimum. Oh, shifting. Always don't forget that midline. I always forget the midline. Dot out that midline as soon as you write it down. So there's my midline. All right, amplitude is 2. So we're going to go down 2 to start. So that puts us at 1. At 6, we're going to be back down at 1. At 3, we're going to be at an amplitude of 2 above the midline, so up at 5. at 2.5, nope, 1.5, we're going to have an intercept. 4.5, we're going to have an intercept. So there'd be 1 revolution. If I wanted to continue that, go another 6, there's 12, 9, and then halfway between that be what, 7.5? Halfway between 9 and 12 be 10.5. Then you can get some more revolutions in for a second cycle. Example 10. Now we're going to do the reverse. Write the equation for the given function that has following characteristics. So we have an amplitude, so sine, amplitude of 3. So 3 sine. My period is 2 pi over 3. So 2 pi over 3 needs to equal 2 pi over b. So that's pretty easy to see that your b needs to be 3. My phase shift of c over b needs to equal pi over 3. We said b is 3. So hopefully you can see that c would have to be pi. Okay, so we got 3 sine, come down here. 3 sine, and then because we found our b, we can just go right to my b, which we said was 3x, and then we're shifting to the right, so minus pi. You could either write it like that, or we could do 3 sine, factor out that 3x, and then minus c over b, which is just the phase shift, right? So then I wouldn't have to do any calculating of what c is. Both are acceptable answers. For b, we have a cosine amplitude of 5. So we're going to have 5 cosine, period. So 4 pi is equal to 2 pi over b, which means b is equal to 2 pi over 4 pi. So b is going to be equal to 1/2. So if I went right to the factored out way, then I could just do x left, so plus pi over 4, and then down 2, so minus 2. So I could write that as my answer. Or you could solve it out. If pi over 4 needs to equal c over b, and we said b is 1/2, so c divided by 1/2 would just be 2c. So that means that c would be equal to pi over 8. See how this is a lot more work. So 5 cosine 1/2 x plus pi over 8 minus 2. Either are acceptable answers, and I would accept either of them. It's a little bit easier to not have to do the work and just go right to your c over b, which is your phase shift. Number 11, write a sinusoidal function with amplitude of 2.5, period of pi. So 2 pi over b needs to equal pi, which means b is going to equal 2. Okay, amplitude's 2.5. So there's my A. And we have an ordered pair that they're giving us that our graph needs to go through to 0. Okay, so let's start plugging some of this stuff in. So y is equal to 2.5 sine of 2x minus some value of c. Now, let's think about this. This is my argument, right? This is representing my angle, my x value of my function. So 2x minus c is telling us that we need to equal to 0, because that's our y value of our ordered pair. And we said that this needs to happen when x is 2, so 2 times 2 minus c needs to equal 0. So we end up getting c is equal to 4. So we can do y is equal to 2.5 sine of 2x minus 4. And again, there's going to be other possible answers that you could come up with, depending on how you transfer it around. But it could also be a cosine, so 2.5 cosine of 2x minus 4. Hold on, we can't just make that cosine. That does not work. If you wanted to make a cosine, it's going to be a lot more complicated. So if we did 2.5 cosine of 2x minus c, and we need this cosine argument to be 0. Well, where are we 0 on a cosine? We're 0 at half a pi and at negative, or at 3/2 a pi. So if I need it 2 times 2, so 4 minus c is equal to half a pi. We'll go that route first. Then 4 minus half a pi would be equal to my c, which that's pretty ugly. So that would be y is equal to 2.5 cosine of 2x minus, make this a square bracket, 4 minus half a pi for your c. So the sign was a lot easier in that case. All right, almost done. Oh, here, so you already have the graph of that first one. So red is the sine graph. You can see how it crosses through 2.0. The green graph is my cosine graph. You can see where it crosses at 2.0. Okay, let's go ahead and finish up our notes. Example 12. Find an equation for the graph, state the amplitude, period, phase shift, and midline. Verify that it works by actually graphing it. I'll just use Desmos for us. So we have a maximum of 5, minimum of 1. So my amplitude is going to be the average of that. So 5 minus 1 cut in 2, which would be 4 over 2, which is 2. My amplitude is 2. Our midline, 5 plus 1 divided by 2 is 6, so 3. All right, what else do we have? A full period looks like we're going, so midline, oh, there we go. So it looks like we're doing a sine. So sine, so intercept, minimum, intercept, max, intercept. So it looks like 4 pi is a whole period. Okay, so if 2 pi over b needs equal to 4 pi, then b is equal to 2 pi over 4 pi, so 1/2. We don't have any phase shift happening if we use a sine function. Our d is going to be 3, and then we're flipping it. So y is equal to 2 sine, b we said is a half, so 1/2 x plus 3. We could have done a phase shift of a full pi for my sine, and then I wouldn't need to do it as a reflection. We could have done a phase shift of 1/2 and turn that into a cosine. So there's all sorts of different things that we could have done, but that's probably the most easiest answer that you can come up with. We verify it on Desmos. So what do we just say? Y equals negative 2, y equals negative 2 sine half x plus 3. So yes, there we are, 0, 3, pi 1, and then we have a maximum happening up here at 3 pi 5, which is what we had on that graph. Beautiful. All right, example 12, last one. Find an equation for each graph, state the amplitude, and yep, same thing. Okay, so we have a max of 2, minimum of negative 6. So my amplitude is going to be halfway in between that, so negative 6 minus 2 cut in half. It's going to be negative 4, well, absolute value of it, so 4. Our midline for my d is going to be negative 6 plus 2 cut in half, so negative 4 plus divided by 2 is negative 2. So let's go ahead and dot that out so I can figure out if I have a cosine or a sine graph. Looks like we have a cosine graph, but we're starting at a minimum, so a negative of that. So y is equal to negative 2 cosine. Or nope, not negative 2, negative 4. Negative 4 cosine. Okay, so my period. So min, intercept, max, intercept, min. Looks like our period is pi. So So 2 pi over b needs to equal 2 pi. So it looks like b is going to equal to 2. So 2x. And then we don't have any phase shift if we do a negative of it. So we are done. Midline is minus 2. So there is our graph. Let's confirm it. So y equals negative 4 cosine 2x minus 2. Oops. There we go. All right, starting at negative 6. Good. Half a pi and 2. Good. And then back down to pi negative 6. Awesome. Again, different answers could have happened here. We could have done instead a phase shift right so that we didn't have to reflect it. So if we did a phase shift to the right half a pi, then that would make this be my starting point, and then it would just be y equals 4 cosine, and then I would factor out our b, which we said was 2x minus half a pi minus 2. That would also get you the same graph. Okay, here ends your notes.